So here's our question. Let f of x equal negative 3x squared plus 12x minus 9. We want to find the domain, range, vertex, and determine where does the function achieve its minimum or maximum. So let's think about this and let's recognize that it is a parabola. And that should give us an idea about the domain and range. But I'm going to start my analysis here with the vertex. And for a parabola written in this form, f of x is ax squared plus bx plus c. The vertex occurs at the point where x is negative b over 2a. So in our example here, we have b is 12, and we have a is negative 3. So negative b over 2a will give us negative 12 over 2 times negative 3. Negative 12 over negative 6 is 2. So 2 is the x value of the vertex. To get the y value will be the value of the function at that x equals 2. So what is that? Negative 3 times 2 squared plus 12 times 2 minus 9. What does that give us? So I believe it is 3. Negative 12 and 24 is 12 minus 9 is 3. So the vertex is 2, 3. So before we graph it on the computer, let's look at the shape of this. The initial term, the x squared term, is negative. So if a is negative, we know that the graph will have this shape. It's going to be a heading down parabola. So we will indeed have a maximum. Now we want to talk about domain and range. The domain will be everything, all real numbers. Which is the same as writing minus infinity to plus infinity. The range, what are the y values? Well, the y values will go as low as you want them to go, and they'll end when we get up to that point. So the range will be from everything less than or equal to this y value. The range will be y is less than or equal to 3. So in interval notation, minus infinity, comma 3, square bracket. But let's go ahead and check this on Desmos and see if that's the case. And then we can answer our min-max question. So let's go back to Desmos. So we'll do that. So the graph that I want to share here is f of x equals negative 3x squared plus 12x minus 9. And I believe the vertex is at 2, 3. And sure enough, that looks like our vertex. And domain, all real numbers, you can see the x's get as low as you want. They go negative, they go positive very slowly. The y values go as far down as you want, but only up to 3. That reinforces our notion that the domain is minus infinity to infinity, and the range is minus infinity to 3. So what about our min-max comment here? F achieves a relative maximum of what? F achieves a relative max of, and we can look at our graph. What was that relative max? It was here. It achieves a relative max of 3. At what point? At the point where x equals 2. Because in that neighborhood, relative max, nothing gets higher than 3. And it's also an absolute max because nowhere on the graph does it get higher than 3.